And we are live. Hello and welcome everyone to Circuit Stream's Intro to Game Development Workshop. Thank you all so much for joining us today. We'll be building a PacMan game today, a clone rather, using Unity's development engine, also referred to as a physics or game engine. I'm your host, Brendan, and shortly we'll be joined by our Unity and XR instructor for today, Arthur Ribeiro, who is a wealth of knowledge. Now, before we get into it, I wanted to do a quick audio video check. Let me know in the comments if you can hear me, if you can see me. Any feedback is greatly appreciated. Emiliano, there's a name I recognize. Good to see you, Casey Chun, Fred. Awesome. Thank you guys. Also wanted to provide a quick overview of your layout here before we begin. So to the bottom right of your screen, of your presentation screen, there should be a little bell icon. Where is that located? If any of the noises or notifications are distracting to you or annoying you during the presentation, go ahead and click that bell icon and it will mute all of those notifications. We also have the comments section. Feel free to engage with other audience members. We also have members of the team here today who are happy to chat. And then if you have any questions throughout the workshop, I would advise you to direct those to the questions tab. We will be doing a Q&A at the end of today's session, so we want to make sure that we are well organized and that we can get to all your questions. That's the best way to organize them. So just if you have questions, please direct those to the questions tab. Now, again, I am your host today. My name is Brendan. I'm an enrollment advisor here at Circuit Stream. I come from a background actually in investment management. And saw the kind of direction that XR was going and wanted to get involved, and Circuit Stream was the best place to do that. Fun fact, I am a competitive rugby player, and throughout my 16 seasons, I have never broken a bone playing that barbaric sport. Soon, we'll be joined by our instructor for today. He's going to be taking over for the technical part of the workshop. Arthur Ribeiro, he joined Circuit Stream with over 6 years of industry experience as an AR and VR developer. He has his bachelor's degree in computer science, and fun fact about Arthur is he can play the jaw harp as well as the ocarina. So for all of you Legend of Zelda fans out there, he may be able to play us a little tune at the end if everyone's lucky here today. Now, what is on the agenda for today in relation to Mike Ribeiro? No, I don't think so, David. That would be neat, though. So for the agenda today, I'd like to take the first 5 minutes to shed some more light on Circuit Stream. The technical part of our workshop today will be approximately 45 minutes, give or take, sometimes longer. Then we'll jump back. Then I'll jump back on stage after Arthur has had that time with you guys, and I'd like to share just a little bit more information on our courses as well as resources. Before we conclude, we'll take 10 to 20 minutes to field any questions you have throughout this workshop. Lastly, as a reminder, this workshop will be recorded and sent to all registrants. If you have to take off a little early, don't fret. We will send you the replay along with the project materials. So who or what is Circuit Stream? So we were founded in 2015. We identified a gap in the demand for education relating to AR and VR. Our goal has always been to share a foundation of knowledge on the best tools, processes, and workflows for Unity, as well as XR design and development. To date, we've helped over 40,000 learners develop these highly sought-after technical skills. So what we have here at Circuit Stream is a global team of industry experts who are passionate about accelerating the AR and VR industry through education. We have team members and instructors all over the world, which also helps us accommodate students across multiple time zones and geographies. Circuit Stream is also a Unity training and channel partner. Partners are approved based on their expertise, focus on quality education, and the demonstrated success of their students. Now, for those of you who are unfamiliar with Unity, they have created one of the most extensive and robust development engines on the market, which we'll shed some more light on very shortly. Our instructors also maintain the highest levels of certification offered by Unity. Our courses also offer internationally recognized XR design, development, and Unity badges and certifications while preparing you to progress with Unity's official certification tracks. Paired with portfolio projects created in each of our course curriculums, we believe this is a great way to display your technical expertise as a professional in this space. We've also been partnering with some of the most well-recognized educational institutions in the world. Our XR Development with Unity course is now even more accessible to students through our university partners, such as the University of Toronto School of Continuing Studies and the University of British Columbia Extended Learning. But who have we actually worked with? Well, we've trained teams and professionals from some of the largest organizations in the world, such as VMware, Walmart, Hershey's, even the US Navy, just to name a few. We work with organizations large and small, right down to the individual learner. But why are all these organizations choosing us? Well, here at CircuitStream, our bread and butter is providing an education on the best tools, processes, and practices for programs like Unity, as well as on the topic of extended reality or XR. For anyone unfamiliar with the term XR, it's an umbrella term referring to any of augmented, virtual, or mixed reality. So I also wanted to give everyone a brief lay of the land with regard to our course offerings here at CircuitStream. And we'll start with our newest course offering. It's a self-paced curriculum that is structured as a 6-part video course. So kind of go at your own pace. This features an in-depth guide on how to create your first app using Unity. We also recently launched our Introduction to Unity 3D Development 8-week course. The live instructor-led course focuses on Unity fundamentals and has students creating while they learn. By the end of the course, they will have created and launched a full application. If you're looking for XR-specific training, we also have our XR Development with Unity for developers and our Interaction Design and Prototyping course for XR designers. Our course offerings include programs meant for beginners as well as intermediate or expert level designers and developers. We also offer one-on-one support and mentorship packages that can be tailored to your learning or as added structure to a capstone project you may have in the works. From our structured flagship development design courses to our one-on-one mentorship and project support packages, we at CircuitStream provide students and professionals with a pragmatic approach to education in a highly technical field, and we supplement this with accessible and ongoing support. We offer these courses on an individual or group basis, and for any of our students or learners looking to attend our XR Development with Unity course through a recognized post-secondary institution, definitely consider enrolling through one of our university partners. Now, what we're going to be learning about today, we're going to learn about Unity's interface and main tools, how to deal with prefabs and new objects, different types of game objects and how to use them in a project, game controls and interactions, and basic scripting and physics. Some seriously exciting stuff. Can't wait. Now, we're going to be relying mostly on Unity throughout today's project. And for anyone, I'm sure many of you are familiar, but for anyone who's not, Unity is the easiest way to begin creating content for a multitude of devices and platforms, including augmented and virtual reality. It's a free 3D development engine for building games, simulations, and experiences. We also know that Unity is used to create over 60% of the world's AR and VR content and is also responsible for an enormous share of the broader content and application market. In fact, apps developed in Unity are downloaded about 3 billion times on a monthly basis. 3 billion with a B, yes. Their software is by and large borderless and can be used pretty much anywhere in the world, bringing a powerful creation tool to creators and innovators all over the globe. Now, today is an intro to game development, building a PacMan clone in Unity. So at this time, I'll ask Arthur to join us on stage here, and he'll actually be taking over the technical portion of this workshop. Arthur.
Hello?
Yeah, I can hear you. Perfect.
Can
Welcome.
you hear me, everyone?
Yeah, you are all set. I'll get out of your way here and take it away.
Hello, I'm Arthur. Let me get the share going. So we'll be creating the PacMan tree, but unfortunately we don't have that much time to go through all of the features on PacMan. So for this workshop, we'll be covering the level layout, the PacMan movement, collecting both cherries and dots, the power palette, which is how you enable to kill the ghosts, and either killing or dying to the ghosts themselves. Okay. Uh, as they said before, this is recorded. So for now, pay more attention to the concepts and the logic. You don't need to follow along because all of this will be made available. There is a GitHub project with every single step that I take on this workshop. So you can not only get the final result, but also go through every step that I do here on the workshop. And please ask questions. There is a tab for the questions. So yeah, go ahead. Now, so the first thing we'll do is create a new project. You can try to follow along, but it's just that I won't really stop to make sure everyone is on pace, okay? But yeah, so we're calling this PacMan. We're creating on the workshop, and for now we're dealing with the 3D because I found a cool asset on the asset store for the 3D, and we're opening. So the asset I found is this one, Jumpman, because we can't really use PacMan. It is free, so if you want, just go to asset store and download it. I have downloaded already. I'm just stalling because Unity is still open. Yeah, okay. Now we have Unity. Okay. So before I start, let's take a look and get to know the Unity layout. So it is divided into windows, this Windows hierarchy, project, inspector. You can change them as you like. So probably what you're seeing is not what I have here. If you want to follow, there's this layout with some presets. I'm doing with this tall one, okay? So the tall one will look like this. But since I also need to see the scene and game at the same time, I'm just gonna drop this here, okay? So to actually understand what's this, on the scene view here, this window is where you place every single object that you have on your game. So if you want to place your characters, your houses, anything, you will place through the scene here. The game view is what actually the player will see on the end. So there is this camera, which is kind of looking in your world here. You can see this pyramid here. So only things that are inside this view will be rendered on the game. So when you are playing an FPS, you can only see what's ahead of you. So that's basically it. So on the scene, you place the whole world and you move around stuff. And the game is what the player is actually seeing. The hierarchy is a more organized way to show you what's on your scene. So if, for instance, I create a cube here, I know that the cube not only is on the scene here, but also on the hierarchy. So I can actually see them, everything that's in the scene. And it also comes with a parent-child relationship. So I can create this like a sphere inside the cube. And the sphere will move like alone, but the cube, since the cube is the parent of the sphere, if I move the cube, the both of them will move together, okay? So this is one of the functions of the hierarchy, not only knowing everything that's inside your scene, but also creating this hierarchy, this parent-child relationship, okay? The project is where you can find all assets. So when we download the Jumpman in a bit, you will see here all the assets that we downloaded from the Jumpman. So the PacMan itself, the borders and everything will all be here on the project. And the inspector is anytime you select something, you can see the details about that. So when you select, for instance, the directional light that we have on the scene, we know that it has a light these are components. These are what's called components, and every object in Unity is called a game object. So when I select the game object, the components that belong to that game objects are shown. Okay. So the main camera has a camera game object, while the directional light has a light. So when I created that cube, it has the box collider and the mesh render. So if you want to understand what is that game object, you basically click it and you will see what's inside that. Okay. So just an overview of everything here. Okay, so next, we actually get the assets that I just mentioned. To get the asset to your account, you need to log in on the asset store and add it to your assets. But I've done this already. So I can just come to window here, package manager, drag the window. It is refreshing. I don't want to see the packages that are in the project because I haven't imported it already. So on the my assets here, you can see the PacMan. Right now it's only import, but if I didn't download, it should be download here. So you just download and then you import. Okay, so this thing here is because the person that created this created the whole project and not just the assets. So I'm just acknowledging that I'm importing a whole project. And I'm going to skip this because I want to do the configurations together. Okay, so I'm also going to uncheck the project settings because I want to do everything with you instead of just getting from the package. Okay, so import. Yeah, so what we're going to get here is we're going to get the meshes. Meshes are basically the topography of the objects you download. So let's say you have the house, you need to know where are the walls, where is and where are like the hole for the door. So this is what the mesh tells us. Okay, the mesh is basically how to build that object that you want. So basically, when we download here the PacMan, we'll have that whole sphere encoded in a mesh object. Okay, it finished. So there is this whole folder for the meshes here. Okay, let me open this. So not only we got the meshes, we got the materials, which is how we paint the meshes, the audio, some textures, and everything. Okay. Now, if we were to create the levels from the get-go, we would go to the prefabs, the environment here, and the maze geography. So the person that did this made it really organized so we can actually see not everything that you download from the asset store is this well organized. Okay. And so what we would do here is we have this knob here. If you slide it, you can either make the things bigger or smaller. And I just want to see the name. So that is why I'm moving all the way to the left. So first we get the ground. I can either put it directly on the scene or on the hierarchy. Okay. So now we have a ground on our scene. Nice. And next we would get the wall. So there is the stage border. Okay. If we add the stage border, this is the border. And so we need to place basically every single thing here and create the maze as we want. For now, we're just dragging and putting on the hierarchy, but we need to move around and actually place them. You do this with there is these tools here. One of them is the transform. If you click the other ones, you see that the gizmo here changes. So this one, the transform will allow you to move it around. And this one will allow you to rotate it around. Okay. So basically, we move it. Oh, if I click with the right mouse, I can rotate where I'm looking on the scene. And if I press WSD, I can move around. Okay, so this is why how I'm getting around on the scene. So basically, we would then position every single wall and create the maze as we go. Okay, and this will take a lot of time, so I won't do this because the assets that we got, there is also this scene called level 1 here, and it basically have everything set up for us already. So the whole process would be get those prefabs into the scene, position them using these tools here, and then when you are satisfied, well, you have your maze basically. Uh, Not only, but you can start from this base as well and modify it to something that you like. So you don't need to keep it like this. I could move things around and make something that is more to my liking. Okay. So basically, most of the assets you get from the asset store, they include a demo scene. So you can start from there and actually see how people how people how he intended to use all the assets he provided to you. So this demo scene is really good for this. Okay, so from this demo, this is what we'll start from. Okay, we have all the hierarchy really helps understanding what we have as well. So we have the whole maze. I can disable here and see exactly what is the maze. So the maze has the stage borders, the internal, so the borders, the internal walls, and the ground itself. There is then the dots and the pallets. So all the dots are here and all the pallets are here. Okay, and then we have the characters, both the enemies, which are the ghosts here, and the chunk man or PacMan. Okay, so this is what we're starting from. And the next thing I want to do, so we got the level placement done. Oh, one thing to know is when you move things, there is this transform component. So the transform always knows the position and the rotation and the scale of that game object. So when I move it around, you can see that the values are changing there. Okay. So when I move the jump man around, so if we make it move like with our keys, we expect that these values to also change as we move. Okay, so just keep that in mind for now. Uh, so back to the assets here. One thing that is a good practice is to I'm going to create the movement for the PacMan now. So we need to create a custom script so we can actually move it around and detect the keys and everything. So to do this, we create a script that is a component that will add to the chunknet. So just like any other component, we create a script so we can add this new functionality to our game objects. Okay. Uh, the the package we downloaded, it already added this character controller. Okay, but I'm not gonna use it. It has a bunch of cool things, like it knows how to bump into stuff. It knows how to climb slopes and stairs, but it won't really help us with capturing the dots. So that is why I'm not gonna use it. But this is something really cool that you should look into if you have time. But either way, I'm going to remove it for now, and we're going to create our own controller. So it's a good practice to always keep things organized. So scripts, we're creating a new folder where we're going to create all our scripts. And now we're creating a C# script that is called player controller. And if I double click this, it will open your IDE. Probably you have the Visual Studio. Okay, and this is mine. Then we make things bigger. As soon as it stops He needs to understand the project. Okay. Finish it. Compile. Uh, how do I zoom it? So whenever you create a new script from Unity, it comes already with this bare bone layout. Okay. So don't really pay attention to all the syntax for now. Just know that we're creating a player controller component. We know that it is a component because it has this mono behavior. Okay. Since Unity creates this automatically, you don't really need to know exactly the word for word this, but the main point is we're creating a new component called player controller. Okay. And it has two functions already, the start and the update. So anytime you see something, a name, and this open and close curly brackets, that's because we're creating a function. Okay. The start function is used mostly to set up anything that you need to, any logic that you need on that component. So maybe you are resetting some variables, maybe, well, this is the setup that you do. It's called only once as soon as you start the game. So you start it, you start playing, sorry, and this function will be called on every single component, okay? And this other one is called every single frame. So this is for setup. This is for actually doing your logic. So if you're going to move, this needs to be on the update because we're moving every frame. Now, you may have heard this, the 60 FPS or 60 frames per second. So when a computer is running at 6 frames per second, this update function will be called 60 times in just 1 second. Okay, so this is kind of the idea. You're always computing and seeing what you need to do on this frame. Okay, so in our case, every time we want to see if the player is pressing anything, and if it is pressing the correct keys, we are going to move it left, right, up or down. Okay. So before I do anything, I want you to know where I need to move, right? So on the Jumpman here, so it moves only on this plane, right? So it moves on this plane. So if you look on the transform here, it basically moves on the X axis and on the Z axis, okay? If it moves on the Y, he's basically jumping, and PacMan doesn't do this for now. Okay, so now that we know where we should move, so let's go back here. We don't need to do any setup. We just need to know if the key was pressed and moved left, right, up, or down. Okay. So the first thing here is if C# tries to look like English as much as he can. So we're just actually asking a question here. If the input dot get key down, get key, sorry, key code. I'll explain a bit. So what we are asking here is, so if we go to the input class and ask, is the left arrow pressed? So this is what this function will do. So this is a function just like this void update. So we're going to this other class and asking, oh, yay, the left arrow, is it pressed or not? How is it? So we know that if this is true, so if this function returns, oh, this is pressed, we should then move our PacMan. So we go to the transform, which is our component. Not all components are available like this, but since transform is used like a lot, that is why transform is always available to you. So we're going to set the position. So we're basically changing that field that I was showing on the inspector. And what we want to do is change the position to wherever it was plus a delta. So if it was here, I want to move it here plus a bit more. So transform position. So this is wherever it was, plus, if you see, this is, if you remember on the inspector, actually, let me get here, it has three variables here. So X, Y, and Z. So the position is X, Y, and Z, okay? So this is called a vector tree. So we're using a vector tree left, which if you hover here, always use this. The IDE, the Visual Studio, helps a lot. So it's always telling you what things mean. And in this case, it's telling us that this vector means -1, 0, 0. Okay. So we're moving left, and this is basically, we're getting the X axis and going to the -1. Okay. And we can do the same for every other one. So if the key is right arrow, we go to right. Now, I don't want to, if I press both left and right arrow, I don't want to keep like going back and forth. So I'll add a else if. So if this one, if the left arrow is pressed, okay, we're never getting to the else if here because we already entered this block here. One other way to show if blocks is this way, so you can actually see what's inside the block. Okay. So if this one is true, we're never getting here. Oh, sorry, if this one is true, we enter this block and we're never getting this one. And we can do the same for the other arrows. So the up arrow, and the down arrow. Okay. Now, you might think that this one, vector 3, would be up, right? But that is wrong. Because if you hover here again, you see it's 0, 1, 0. And if you remember, we're moving the Z and not the Y, okay? So this is wrong. What we want here is actually the forward. So the forward is 0, 0, 1. So we're moving on the Z axis, okay? And this one will be back. Okay? So this is just a simple movement. Let's go back here. Now, if I were to play it right now, nothing will happen because even though I created a new component, it isn't attached to the game object. So it doesn't matter at all that I created this unless I put it somewhere. And for now, I want only the chomp to move, because if I added this same component to multiple different objects, all of them would move as I press the keys, okay? So let's play and see how it plays out. So I have here, and it's way too fast. Now, if you remember, but I can go basically all ways. Remember, I said that the update function is called every single frame. So this is one of the reasons why it's like super fast. So what we want to do here is we're going to multiply this vector. So the idea is still the same. We want to get the same position and apply a delta to it. But this delta is way too big for now. So we want to make it frame independent, especially because if I were to come back here, there's this stats thing here, and it shows this FPS here. So now I'm running at 140 frames per second. But you can see that it varies. It isn't something that just is always that same FPS. So this is what we call making something frame independent, because we don't want my computer to run in the PacMan in my computer to run in a different speed than the other. So what we do is we multiply this by time, delta time. Okay. This delta time, again, if we hover, it's the interval in seconds between the last frame and the current one. So how much time passed between the last frame and now. So we make sure that even if the frame is super fast, because like we're computing super fast and my computer is really good, we don't care because this delta time will be really small. So that actually the actual delta here won't be won't be as high. And we're going to move. Everybody will move at the same pace. Okay. So now we make this delta time on every single one here. Nice. Now we'll have a really slow PacMan. And this is the part where we add some balance. Because maybe, let's say you're creating a platform, Mario, for instance, and you want it to run a bit faster or run or jump a bit higher. You don't want to keep coming back to the code every time you want to make a change and balance that out and test different values. Okay, so this is why we create a variable here, public float velocity. And the first thing is, why is this outside the update? That's because on functions is where you create the logic of what happens when the update is called. And these are what we call class variables. So let's say we had a human class. I could say my name is Arthur. I have 29 years old. So these are like the information about myself. And I can eat, I can run. These are the actual functions, so what I can do. So this is some information about the player controller, so how fast the player controller goes. And this is the logic of how to actually make the player move. Okay, so logic and values that you want to store and use later. So this is basically what a variable means. And the float one, just like the vector tree, so the vector tree contains the x, y, and z. Now the float data type, this is called data types. It is a number, so that's basically it. I want to move faster, so I increase that number. But there is also another number called int here. Okay, that int stands for integer, so 1, 2, 3, just like math. -1, -2, so from minus infinity to infinity, but no decimal point. The float has decimal points. So this is basically the idea. And we're using float because if you remember, this is .43, so we need the decimal points, okay? So, okay, now I would have to multiply everything again, and this is really horrible programming. So what I'm going to do is I'm going to create a vector tree. So I'm creating a variable of this data type called movement direction. Okay. And I'm going to initialize it with 0. So if I'm not pressing anything, it will be 0. And instead of doing all of this every time, I'm going to just grab one of this and place it on the bottom. So if I get the left arrow, the movement direction will be equal to the left. So basically, I'm just storing the direction on these ifs, and this last piece will actually make the movement. So I get the movement direction, I make it frame independent, and then I make it a bit bigger with the velocity. So let's update all of this. So movement direction, this one is right, this one is forward. So you see now, if I want to change how the movement goes, I just have to change here. And if you see, this is the same thing as this, meaning I created a new variable. So a variable is somewhere you can store a value to use later. But the difference between this one and this one is this value, it belongs to the player controller as a whole, whereas this movement direction belongs only to the update function. Okay, so as soon as the update function reaches its end, so it executes everything, this variable stops existing. Okay, so this only works while we have it here. Okay, and now if we go here, well, the velocity is still 0, so let's go to 7. I think. And now we have it better. One of the good things of having this exposed is because we can play around and see, oh, this is too slow, 10 is too fast, and whatever. So we can test around and see whatever we want and keep it, okay? But as soon as you stop playing, this value will return to what it was. So if you ever do any changes while in play mode, remember to come back here and reapply the value, okay? But if you remember, PacMan doesn't stop. It starts going one way, it will always go that way. So if I just stop pressing, it shouldn't stop pressing. And to do this, the only thing we need to do is just get this one and make it a class variable. So when the update function stops, this thing here won't stop existing. So this will always exist. And even if we don't press anything, that movement direction will keep the same value it had before. Okay. So I hate this thing here. So I'm going to create a new function just to organize things. This is called, just a moment, let me see how I named this. Set movement direction. So right. So just creating this, I'm creating a new method, okay, just so I have a better idea of what's actually happening. Because if I just keep everything on the same function, it slowly becomes really hard to understand what you're doing. So right now, we basically changed this to set movement direction. And now if I were to just read the update, it's super simple. We first recompute the movement direction, and then we do the actual movement here, okay? And I can ignore how we do this because I know that this one is already working, so I don't need to concern myself about this because I just need to concern myself with the rest part of the movement that I'm creating, okay? So, and this is really way easier to understand. Well, so just to test it out, now it should keep the same direction as I play. So, oh, I didn't start playing. Okay. So if I just stop pressing, it will go. Nice. One thing is that PacMan is not looking to where it is going, right? So we need to fix that. So to fix this, again, the transform has all information about position, rotation, and scale. So if we want to change the rotation, okay, we go with, we change this value, the transform rotation, and there is this thing called quaternion, which is a fancy way for rotations. We can use we can go from the Euler, from the XYZ rotation, but Unity uses quaternion because it's a bit faster. What we are actually going to use is this look rotation, and I don't know if you can read it, creates a rotation with the specified forward and upwards direction. So we have the forward because the movement direction is always where he's going, right? So we already have this, and we just need to pass it to that function. And now we are rotating to the same direction. And that's how we do this, okay? You see, there is this thing here. Okay. If I were to open this, this is what we call a console. It's telling us something. So let's say if I were to go wrong, like there is a missing thing here, it will tell us, oh, there is a missing point, semicolon there. So it's really good to keep the console open, not only to see what you can use to debug. You can write messages there, okay? But yeah, so it's saying that we are trying to look with a vector 0. That's because it starts with a vector 0. So let's just change this. So as soon as the game starts, you're going right, no matter what. Okay, so, but right now, if you see the PacMan is going through the, the walls. And that is because we're using the transform. So the transform basically positions the things around the scene, but it has no idea whatsoever about any physics or anything. It isn't a part of the physics system. If you want to make it a part of the physics system, we need to use the rigid body. This is a component that will, will this is really like this object now should be simulated on the physics. So we have a mass, we have a drag. We don't want gravity for the PacMan because it always stays on the same height. Okay, so you can basically change a few things of how this uh, simulation will go. And this rigid body uses the collider to know when something bumps into one another, okay? And with this collider, this is what will tell us that we collided with the walls. And if you click the wall, it also has a collider. This one is a mesh collider, and the PacMan is a sphere collider. Doesn't matter. The sphere, if you see like this green stuff here, this is what the actual collider looks like. And these other green lines are what this collider looks like. Okay. But if I play it now, uh, actually I need to change a few things in the code, but there is the PacMan is set as a trigger, and this is wrong. So a collider can work in two ways. It can either be something that you actually collide with and you bump and you can't really get on top of each other, okay? Or it can be just an area that you know when something enters or not, okay? And right now we want it to bump, so this thing here shouldn't be marked as trigger. And okay, so we're using the transform, but the transform has no idea about the physics of the physical simulation. So we need to change this to a rigid body. So first thing, we need a reference to the rigid body, because the transform, remember, transform is really used by everyone. So this is why it's super easy to get it. But other components, you need a reference to that component. So that is why we create a rigid body here, and that's called RB. And what we'll do is we'll get back that start function. So this is our setup. And during this setup, we set the RB variable to a get component rigid body. So this function here will look in that game object for this component. So if I come here, I have this player controller. When I use get component, it's checking all of these components and trying to find something that matches. So I'm looking for a rigid body, it will find. If I was looking for a collider, it will find a collider. So now that I have the rigid body, this is really simple because rigid body has a position and rigid body has a rotation. Okay, so but we don't want to do it like this. Sorry. Because if we did this, we would basically teleport the PacMan to one place to the other, okay? And that's not how physics work. So there is a function called move position. So it moves the kinematic rigid body towards that position, which is basically go to that place, but simulate that you're actually going that place. So don't just teleport there, okay? Which would happen if I just set the position to that place. But the idea is still the same. We're getting the previous position and applying a delta. Okay, so it's kind of the same. It's just that this function here will simulate the translation instead of just, oh, you're now in this place. Okay, So if we were to play it, I'm not sure how much time left I have. Okay, but it's bumping issues, as you can see. Nice. Okay. Next thing is I want to collect the dots. So on the dots here, let me get the dots. Okay. So every single dot is under this game object here. And unfortunately, this isn't a prefab. A prefab is basically a preset of how a certain object should be replicated. So I'll have to modify all of them together. So to do this, I select the first one, go all the way down, shift click the other dot. So I'm selecting everything. Okay. So what I need is I need to know when it hit the PacMan. So when PacMan went over it, but I don't want it to be like to keep bumping into the pellets. So if you remember, this is what the trigger collider is for. So let's add a sphere collider, make it a trigger, and that's pretty much it. Now, if we go to the PacMan, the way we know when something entered a trigger is private void on trigger enter. So if you see there is on enter, exit, and stay. So we know when it entered that area, when it left that area, and when it staying on that area. This stay will be called in similar to the update function. Not as much. I think it's but yeah, it will be called a lot. So on trigger enter, it receives, this is a parameter. We've been using this already. Like when I go to this look rotation and set this movement direction here, we're basically calling this function and providing this information. Okay, so this on trigger enter function receives this information. So not only we know when something entered, we know who is that entered. Okay. So for now, I just want to know if it works. So I'm going to create this log here, and let's see if it's working. So when anything that has a trigger enters, this should be fired on the console. So this is basically creating a log on this console. Let me change it from here to here, because the game view always goes on top. So you see on trigger enter, on trigger enter. So every time we go through a dot, we get this. So we need to do this now for every single thing. So for the ghosts, for the cherry, and for the power-ups. Okay, but we need also to be able to differentiate between one and the other. And to do this, we use one thing called tags. You see here, every game object can be tagged. Okay, so we're going to create a new tags. So there's the dot, there is the ghost, power, palette, and the check. Okay. So back to the dots. Now I have all these tags that I can apply to the game object. So I select again every dot, come here, and these are tagged as a dot. Select all the power palettes, come here, set it as a power palette, add a sphere collider because we want to know when the trigger enter, and set it to trigger. Where are the ghosts? So the ghosts are here. Select all ghosts. So the ghosts aren't spheres, right? So I'm not going to use sphere. I'm going to use this capsule collider. This is really an approximation. I could use other colliders, but if you see, like if I zoom in and enable the gizmos, you can see like that these green lines, they are kind of good enough around the ghost. Okay, so I can use it. And if I were to actually select the dots, you can also see the the collider here. Okay, nice. So the ghosts come back here. They are tagged as ghost, and it is a trigger. And finally, the cherry tagged as cherry, and is a box collider, also a trigger. So this one, I thought box collider was the best one. Again, PacMan isn't super like, oh, I need to have perfect collision, so it doesn't really matter. So let's see how to differentiate between those. Uh, First, I like to keep things organized, so I want to create a few functions. So private, void, dot collected. I need a collider on this. And I'm going to create basically a collect for every single one. So dot collected, our palette collected, carry collected, and finally goes collision because don't collect goes. Nice. And how to actually choose between all of these functions is on the trigger enter here. We again ask, so if the other, which is what collided with us, there is this function called compare tag. And you see it returns a boolean. It shows here it returns a boolean. Is the object tagged with? Okay, so always use your IDE. This is your best companion. So if the tag is dot, then we dot collected. And else if other compare tag ghost collision, so on. Okay. So again, I want to make sure this works. So debug log collect. Always testing, because if I just do a bunch of stuff and something is not working, it's way harder to actually find out what's not going. So the dots collected, you can click collapse here. So everything is just like there's this number of how many times it was collected. So ghost is working, carry is working, and power palette as well. So nice. Okay, so let's do some score. So first we create a public for now, just so we can see int score. And when the dot collected, we go score plus 1. Oops. I will also want to destroy the dot. So I collect, I add the score, and I then delete that object. So other game object. If I just press the other, I would be deleting the collider, but I want to delete the whole game object. So that's it. So, and I always press it twice. See the dots are moving out, and if I would select the Jumpman, the score here is 15 already. That one is working, but I don't want to keep it like this. I want to see the score, so let's create something to see. We use this UI. I'm going to use the Text Mesh Pro. It opens this pop-up, and you want to import the essentials. This is basically some fonts and stuff to make this text work. I want the text anytime you create a UI something, it will also create a canvas, which is basically where your UI elements are. And you want to set this to scale with screen size. So I'll pretend that my reference is this much, and that's it. And now I want to position the text. So the text should be, you can see now that new text is here. I want it to be on this part of the window. So I'm going to change first the anchor. So it should be anchored to the top here. Sorry, to the top here. And I want the left to have a bit of a margin. So I'm going to go with 50. The position, I also want to make it a bit lower. So minus 50. Okay, so now it is right here. This one can be 0. And okay. Now if I set this score equals 0. And I'll make it a bit bigger. Good enough. Okay. So now I have the UI. I just need to change it because for now it will just look like this forever. So the way we do this is we get a reference to that that component. If you remember, this is the component text mesh pro text. This is called a public EMP text. And this is the score text. This is just the name of the variable. Now I don't want to see this anymore on the inspector, so I'll make it private again because we don't need it there. And again, I don't want to keep repeating myself because the cherry collected will also do the score plus whatever. So what I'm going to do is private void add score. And it receives an integer, that's the delta, and it goes score equals score plus delta. So I'm just increasing the score just like I'm doing this, but I'll also set the score text to score, and score. So this way here, sorry, not score text dot text. So this is the component and this is the variable inside that component. This is a way to create a new string. So it starts with score and then it uses the value that is stored on this variable. Okay. And now instead of doing this, I'm going to do add score. And I want to change how much points I get from dot, cherries, and ghosts. And if you remember, it's always good to leave this exposed so the game designer can tweak it around. So public in score for dot, which is 10. Just creating numbers here. This one is 100 and this is 200. So score for cherry, score for ghost. Okay, so this one is score for dot. And the cherry should be score for cherry. And we should also delete the cherry. And for now, let's leave the ghost like this because it's a bit different. Now, if I were to play it right now, I just declared that I need a reference to the score text. But unlike the rigid body here, the rigid body, we got it from the same game object. But this one, we don't have it for now. So we need to come to the cherry here, not the cherry, the chomp. And you see, you have this field for the text, okay? So we just go to the text and drag it here. And now we have set that reference instead of just wanting a reference. So if I play it, I have 10. Okay, so things are going. I have also the cherry working. And yeah, so far so good. Nice. So we have most of the score done, and we can also change these values if we want to give more score or less score for the cherry or whatever. Now let's make the player lose if it hits the ghost. Okay, so I'm going to create a new text here, and it's called game over. Let me change this. This is the score text. On the game over, I want it to be anchored to the middle, but fill everything. And I want to be on the middle and middle here. You lost, so this way, I want an outline. The outline is a bit bigger. And this 70, 100. It's too big outline. Yeah, good enough. So when we hit it, I'm going to show this game over, okay? And basically stop the character from moving. So let's do this. Again, I need another reference. I'm not changing the text right now, so I'm just going to get a reference to a game object as a whole. Even though it is the game object with the text, since I'm not changing the text, I don't care about the text, I can just go with game over with a game object type. Okay. So when we hit the ghost, we go enable equals false. What is this? If you see every component, not every component, but most components have this checkbox here. This checkbox is if it is enabled or disabled. So if it is disabled, the update function won't be called anymore. So basically, we won't be able to move anymore. So I'm disabling the movement, and I'm showing the game over text. So set active, true. Now, I'm also going to make something here. I want to make sure that the game over text starts disabled, just for hear my concepts, because probably the only thing you needed to do is this, but it's this is what the set active do. He enables and disables the whole game object, okay? But it's really common, like if I have to change something, I just forget it enabled, and suddenly you have a broken game. So it's a good practice to disable this. So yeah. Oh, sorry. There is missing the reference here. So this game over text. So if I press here, okay, game over, and I can't move anymore. Nice. Okay, so power up. To do the power up, I need to, for some time, be able to kill the ghost. So the first thing is how much time do I have to kill the ghost? So we're going to create a public float power up duration. I'm sorry. And this should be like 10 or whatever. And now I need to know how many remaining time on the power up we have. So private flow remaining power up. It will be set as we go. And I want to know when the power up is active. So basically when this is bigger than 0. So private flow is power up active, is equal to remaining and so this will make the remaining power up time equals to power up duration. So it will reset to that duration, and On the ghost collision, what we check is power up active, and we basically kill the ghost, else we lose. So if we kill the ghost, we're going to do the same thing like this one. So we add score for ghost and destroy the ghost. This isn't exactly what happens. The ghost should go back to the center of the stage, right? But this is for home. And now we need to decrease this. So again, you update it's called every frame. So we just come here, remaining, and remove it by the amount of time that passed between one frame and the other. And that's it. Let me just keep this disabled. If I press it now, it's game over. But if I go to the palette, I can kill it. I forgot to kill the palette. So this should be fine now. And set the palette and two ghosts. Palette. If there's time, yeah. So yeah, and you see the score is also updating as I kill ghosts. So next, we need to make the ghosts move around, and you can, if you want to expand this later, there is this thing called nav mesh agent, and the nav mesh itself you can find on the Unity documentation, and I think yeah, and then counting all the dots so you can actually have a end game as well. And I think that's it for me. Brandon? Hello?
Brilliant, Arthur. Much appreciated. Looks great. Awesome. So I will jump back on here. Really appreciate it, Arthur. Obviously, that's a classic game that you just created. And is there? I didn't hear. Were there any waka 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 sounds, or is that something you have to add?
Oh, it's something we have to add. It's actually simple. On those functions I created, it's just there's like the hook is you just have to place it there.
Okay, awesome, awesome. Well,
And
thank you so much.
I think you have the audio when you download the asset from store as well.
Oh, okay, awesome. So is it kind of like you just plug in and you get the audio effects too? Okay, wicked. Awesome. Well, thank you very much. I'll take over. I'll share some more information just about like Circuit Stream, our courses, things like that, and then we'll get you back on here for the Q&A. Looks like we have a few great questions from our audience members that I will definitely need your help answering. Sounds good.
Oh, I think I removed you. I was on that side the other way. Sorry.
All good, all good. Awesome. So I will hop back on here. Excellent. So round of applause for Arthur. Always appreciate the wisdom you impart with us. So I just wanted to talk a little bit more about Circuit Stream and our course offerings, just so you have that information available to you. So before I delve into each of our course offerings, I want to mention that none of our current course offerings require previous programming or XR design experience. Beginners are welcome. So that's right. All of our courses here at Circuit Stream are beginner friendly. Fear not if you have no Unity or XR experience just yet. And then we have sorry, just one moment. Oh, there we go. Dayon. Awesome. The only requirements are that you have the hardware that is capable of running Unity. So for any of our XR courses, ideally you also have a device that you can use to test and run applications on, but even that is not a hard requirement. The nice thing about our programs, they are all platform agnostic. So they're designed to provide you with the ability to launch applications on a multitude of devices, whether you prefer headsets like the Oculus Quest 2 or mobile devices like the Android or iPhone. And personally, before we even get into the courses, one of my favorite parts about the education we provide has to be our Circuit Stream community. It's a great place to network, collaborate, or participate in events like game jams. It's also where the enduring support for students and alumni resides. So we have open office hours 5 times a week with our instructors that are available to existing students as well as all of our alumni. Now, this is great for continued learning, for troubleshooting, and even project support. And I want to give a massive shout out to Lucy, our student experience coordinator, who's also mixing things up regularly in there with coffee hours, showcases, and events like Demo Day, where our students are invited to share their personal projects and stories. Now, all of our flagship courses are live instructor-led curriculums and have plenty of avenues for enduring support for both students and alumni. Our Introduction to Unity development is a beginner-friendly course that has you concentrating on Unity's fundamental systems, processes, and best practices for development. Throughout the 8 weeks, you are applying what you learned to build a culmination project. Similar to our XR programs, this course is delivered twice a week, with each live session being an hour and a half in duration. And there we go. Dan says we have a demo day next week. So keep your eye on the YouTube channel because we also release those demo days on YouTube. So you gain lifetime access with the Introduction to Unity 3D development course to our community, receive a Circuit Stream badge of completion, and receive a Unity user certification as well. The course tuition is $2,500 US. And then the next cohort starting will be on February 14th. Now, our XR Development with Unity course is also a live instructor-led curriculum that is a project and portfolio-driven learning experience supplemented with opportunities to acquire an XR industry-specific certification from CircuitStream. And you will leave the course with up to 7 portfolio projects as well as hands-on experience with augmented and virtual reality development. So both AR and VR are tackled. The course tuition is priced at $3,950 US, and the next upcoming cohort is going to be February 15th. Now, both of our beginner-friendly XR courses are structured very similarly. So with our interaction, design, and prototyping course, you can expect the same project-driven, live instructor-led format, complete with its own XR designer-specific certification. Like the previous 2 courses, you will also have lifetime access to the supportive community, as well as your class recordings for convenient viewing at any time in the future. The course is also priced at $3,950 US, and the next cohort will begin on February 7th. I also wanted to share a simple visual to give you an idea of the certifications offered with each of these beginner-friendly courses. The Introduction to Unity Development course will reward you with a certificate of course completion and an earned Unity user certification. XR Dev with Unity will help you achieve CircuitStream's XR Developer certification, and Interaction Design will help you achieve CircuitStream's XR Designer certification. Now, many of our students ask about what comes after graduation and how do we get involved in this space professionally. We believe nothing says I'm an authority on the subject matter quite like having an established portfolio and relevant, well-recognized certifications to suit. And for anyone who's already quite advanced but are looking to add structure and external support to a capstone project, definitely take a look at those one-on-one mentorship and support packages as well. Now, one more quick note about our beginner-friendly XR courses specifically is we have the standalone option, which includes your desired course, so either the development or the design course. We're also currently offering a plus package, which includes either of our 10-week courses, but also our C# scripting fundamentals course and 10 hours of dedicated one-on-one time with an instructor, which we recommend using for a project or for further learning on topics maybe not covered in the curriculum. So for those additions, it's $4,950 US, so an extra $1,000 for tuition. Now, for any of our courses or options, we do have payment plans available. So we have 3, 6, and 12-month terms that will just help you kind of manage that cost over time, and they can be applied to either of our XR courses or XR course bundles. Now, feel free to visit our site if you'd like to learn more about any of our course offerings. You can check us out here at circuitstream.com/learning. And if you'd like to chat more in depth about your Unity or XR education goals, or perhaps learn more about CircuitStream and any of our course offerings, contact our admissions team. So Rohan, Leanne, Tyler, Christina, or myself will be happy to connect and have a conversation about finding your best approach. Now, lastly, I wanted to thank everyone for joining us today. Definitely wanted to thank Arthur for taking the time to show us that. The PacMan kind of process for development there. And at this time, I'll ask Arthur to actually jump back on stage. We're just going to close out the workshop today with a Q&A. And I have Indica there, but Arthur is the instructor today, the star of the show. So we'll jump on to the Q&A. And I'm just going to order these, Arthur, and we can kind of go through them individually. So our first question is from Emiliano. Any suggestions about how to create the AI to move the ghosts?
Yeah. So actually, let me open this. Like I said, there is this component from Unity called nav mesh. It will map the whole map for you and tell you where can you move to. So basically, you can say, "Oh, I want to move to this place," and the ghost will do this for you. So basically, what you need to create is the logic to know where to go and now how to get there. So the nav mesh will deal with this, and the logic is like when it leaves, it needs to go after the player, and when you kill it, it needs to go back to the center. So it's pretty much this.
Awesome. Thank you, Arthur. And great question, Emiliano. Eduardo asks, what is a reference? Do you think it is helpful to learn how to use visual coding in order to help coding?
I don't think it's. I think it's helpful in the way that visual coding will tackle only the logic of coding, which helps a lot and when you are coding. But I don't think it's necessary, but yeah, it helps.
Perfect. Thank you. Question from David. I am wondering about how to detect pressing multiple keys at the same time.
So the way I did this, there is this, sorry, not here. I did this with this else if, right? If I just remove the else, I'm detecting multiple keys right now because I'm checking, oh, is the left arrow, do whatever. If the right arrow pressed, do whatever. It's just that in PacMan, you either go right or left, like you don't do any different than one of the basic directions. So that is why I'm using else if. But if you just put one if after the other, you're checking multiple keys.
Beautiful. Another question from David. Are you using the new input system or the old input system?
I'm using the old mostly because it has no setup. I can just like start and begin typing and without actually having to do any like create any asset or anything. But if you can, I would definitely recommend using the new input system. Okay, it's just that for this, the logic is still the same. It's just that I would approach it in a different manner. But yeah, new input system way better.
Okay, great. Thank you. Next question is from Glenda. Hi, could I ask how diagonal movement would work? Is there any way to specify the vector?
Yeah. So if you remember this, so this is a vector, and as you can see, like it can have any value. Okay. The way I did this is because we're always going like on the cardinal directions. But if I can like create a new variable here, like a variable, and set it to a new vector. And when I do this, I can set whatever number I want here, like the -11 or -100 or whatever. Okay, so even like the position, if I get the transform position, this is a vector tree with different values as well as like 1, 0, 0 or anything. So you can create your own.
So a lot of flexibility there. Okay, great. Question from Ashmet. What about if you add multiple events?
What do you mean?
This question seems like it may have required a little bit of extra context.
Yeah.
Um,
Events.
Ashmet, if you are here, would you be able to expand on that question just a little bit? And while we're waiting for that, I will move to the next question. Another question from David. Would it be better to find out custom character controllers either on the asset store or on GitHub?
It depends. Like the PacMan movement is really, really specific, right? If you get any other movement like an FPS controller, it won't move like on like a PacMan. So maybe for the PacMan, I would do create on my own. But if you're creating more like standard games, you can probably find really good stuff on either Asset Store or GitHub. Uh, Maybe sometimes the downside is like you need movement and jumping, and the guy does like crouching, running, and flying and swimming. Like maybe you will get more than you actually need. But for starting and prototypes, definitely you should get controllers from Asset Store and GitHub.
Okay, great. And then we got a response from Ashman. I think he's just typing out a little more to his previous question. But thank you, Eduardo, for that. New question actually. So that last one was from David. My apologies. So in regards to reference, could you explain what is a reference, please, and thank you in advance.
Okay, so there are multiple data types. One of them is float, another is integer. These things here are strings. Okay, so these are the basic data types. But you can, like we did, we create classes. When we have a variable that the data type is a class, we call it a reference. Okay, mostly because when you have without trying to get too much into actual C# and how they store the variables, that's just the way we call when we have a variable that the type is another component. So it kind of makes sense because let's say we have the go spin here and I want to interact with the dots. So I'm getting a reference to whatever component I need to interact in the dots. And this is why we call it reference, because we're basically going to the other place and interacting there instead of having the integer value myself. Okay, so this is somewhat the idea. But anytime you have a variable that the data type is a component, you can call it a reference.
Beautiful. So next question is from Ricardo. How do I know when my programming skills are good enough to start looking for a game dev job? Okay, so a little bit different from the previous technical questions we've received.
I wouldn't wait for it to be good enough. I would just try getting and like try to do as many. I like to do. I don't know how you like to study. I really like to do projects, and if you can, at least how I got my first job is I just showed one of the games I had developed. And if you can develop this, like even if you are just starting, usually the companies they help you out as you go. So yeah, just create portfolio, do your best, and I would just start trying to look for jobs regardless.
Yeah, great advice. Like get started as soon as possible, and I think a big consideration for the curriculums we've created is that whole portfolio component. Like we want to teach you, of course, like very useful useful skills for development, but creating those projects along the way is not just going to help you kind of understand and create more concrete skills, but it's going to give you something to actually show and say, here, this is what I've done. This is what I'm capable of doing. And it's just a good kind of display of expertise. Great question, Ricardo. So do we have any other questions? Portfolio power, says Dayon. Yeah, exactly. Awesome. I think we are all set. Does anyone have any last minute questions for Arthur today? Looks like we are all set. Awesome, Arthur. Really appreciate your time. Again, thank you everyone for joining us. We run these workshops regularly. We also have open houses just to kind of share more information about who we are and what type of education we provide. So definitely stay posted, and that's it for now. So everyone have yourself a lovely rest of your evenings wherever you are.
Bye-bye.
Bye for now.